Let's see, if I plug 0, if you're curious about this plus sign, it's just because think about ln of x, right? This is the graph for ln of x. I have an asymptote right here because the domain of ln of x is 0 to infinity, 0 uninclusive. So I can't ask you this question if I don't have the plus sign. So if you're curious, just keep that in mind. All right, if I plug 0 in, I'm going to get, let's see, I'm going to have 0 times infinity. That's interesting. We're not almost, or we're almost here. We're not quite there. So what we have to do is we have to make this guy a fraction without completely changing it. So we have to be careful about how we rewrite this. So let's just think about our exponent rules here. If I keep ln in the numerator and I want to make this a fraction, I can put x in the denominator as long as I do this, right? Because 1 over x is the same thing as x to the negative 1, right? So if I'm positive in the numerator, then I can be negative in the denominator, okay? So really, whenever you see something like this, guys, just think, put the reciprocal of one of the terms in the denominator. Just go with the easier one, because you don't want to take the derivative of 1 over ln x, but 1 over x is fine. And I think if you went to class the day we did this worksheet, you saw this problem too, right? Okay, so let's see. If I plug in 0, I'm going to have infinity over infinity. Great, we're good. So now L'Hopital has our back. So we have limit x goes to 0 of, the plus side, of 1 over x. That's the derivative ln of x. And then we're going to have negative 1 over x squared as our derivative here. Now, you might be like, all right, let's just plug in 0. Oh my gosh, we're still infinity over infinity. Well, hang on. Slow down, because look at, let me do some algebra here for you. Let's clean this up a little bit. If I divide by a fraction, it's the same thing as multiplying by the reciprocal, yeah? So this is the same thing. Well, x cancels x. This limit is really just limit x goes to 0 from the plus of negative x, which if we plug in 0, we just get 0. 0 can be a solution. 0 over 0 cannot be a solution, okay? So just keep those straight in your head, okay? All right, last L'Hopital's rule. This is the third case of problems. So this is not this yet, right? I have something raised to an exponent. If you're confused, this is limit x goes to infinity x, and then the exponent is 1 over x. I can see how that's not quite written the best, but hopefully that clears it up. All right, any single time you see a function raised to an exponent and you're doing a limit, always think e natural log. Why? Because if we apply natural log to x to the 1 over x, we have these funny things that we can do with exponents and natural logs, right? We can bring the exponents down. So that's going to help us get rid of the exponent and help us get here. Okay? So again, when we did it up here, we had to be careful about not changing the original limit. Same thing here. We don't want to change the original limit. So if I want to apply natural log to this limit, I have to raise e to the entire limit because ln and e, kind of have this funny relationship, right? Where they cancel each other out. All right. So without plugging an e here, if you just left it like this, your answer wouldn't be correct. Because these guys are not the same. They're only the same because it's e to the limit of the natural log, okay? So now I'm going to kind of forget about e for a little bit, and I'm just honestly concerned about this limit. And then my answer is just going to be e to that limit, all right? So we're going to have e limit x goes to infinity. We're just going to do algebra right now. We get 1 over x ln of x, which is the same thing as e limit x goes to infinity ln of x over x. All right, let's plug in to see what we're doing with our limit. If I plug infinity into that, natural log grows forever. Its range is negative infinity to infinity. So this is infinity over infinity. Yay. That means L'Hopital can help us. Okay, so let's go ahead and apply it. So we're going to have e limit x goes to infinity. Derivative of the top is 1 over x. Derivative of the bottom is just 1. So it's just 1 over x. Okay, let me plug in infinity. What do I get? I get 1 over infinity. Well, 1 over infinity, that's a number divided by a really big number. That's 0. So my limit is equal to e to the 0. What's anything raised to the 0 power? 1. There's our solution.